Phylogenetic trees are used by biologists to show evolutionary relationships among organisms. In many ways, a phylogenetic tree is like a family tree for the living organisms on Earth. They both make it possible to visualize what individuals are closely related to one another, but unlike a family tree, phylogenetic trees are hypotheses and are not the absolute truth. Scientists use the knowledge available to make phylogenetic trees that are the most likely to represent evolutionary processes. Phylogenetic trees have been used by biologists to show speciation events and the evolutionary history of organisms. This has allowed for biologists to classify evolutionary relationships across organisms into different categories. In order to understand how a phylogenetic tree can represent different evolutionary relationships, it's important to understand the basic components of phylogenetic trees. The nodes are the points where two lines diverge from one another. This point represents the common ancestor of two groups. Branches are the lines between nodes and crown groups. They represent time and evolutionary history between divergence events and crown groups. The development of new traits are labeled along these branches. Taxa are the organisms or group of organisms at the end of the branches, and the root orients the tree. It represents ancestral lineages that are not necessary to understand the tree itself. In order to read a phylogenetic tree, you start at a taxa and follow the branch towards a node. When a tree is read properly, it is possible to determine what groups are closely related to each other. For example, in this tree, birds are more closely related to crocodiles than turtles, because birds and crocodiles share a more recent common ancestor. Now that you understand how to read a phylogenetic tree, we can now talk about the three types of groups that scientists classify evolutionary relationships into. The first one is a monophyletic group. This is a group that shares common characteristics due to common ancestry. In order for a group to be considered monophyletic, it must include the common ancestor and all of its descendants. Tetrapods are an example of a monophyletic group because the common ancestor and all of its descendants share the characteristic of having 4 limbs. The next group is a paraphyletic group. This is similar to a monophyletic group because the characteristics are shared due to common ancestry, but it does not include all of the descendants of the common ancestor. An example of a paraphyletic group would be reptiles. The word reptiles is often used to refer to groups such as turtles and crocodiles, but is not meant to include birds. The last group that scientists use to classify is a polyphyletic group. This is a group that shares common characteristics, but it's not due to common ancestry. An example of this would be bats and birds. Both of these groups have wings and the ability to fly, but do not share a recent common ancestor. So in conclusion, phylogenetic trees are used by biologists to visualize and classify evolutionary relationships between organisms.